Hi everybody, my name is Jay Warrick. I'm going to tell you a bit today about JEXperiment, or JEX for short. This is a project that we started back in around 2005, Erwin Berthier and I, while we were graduate students in the MMB lab under Professor David Beebe at the University of Wisconsin-Madison. In the MMB lab, we specialized in making microfluidic devices for clinical research and cell biology. And one aspect of doing microfluidics is that you can miniaturize assays down to a very small footprint. So we can put these assays and array them and put them in the footprint of like a 96-well plate. But beyond that, we also can interface these devices with liquid handling automation. So as you can imagine, we can generate a lot of data very quickly across a range of experimental conditions. And so if you have imaging endpoints, the logistics can get a little bit tricky. And that's what we ran into. Is we had trouble organizing and annotating our files, but also trying to use all this information and analyze it. And so we needed a way to batch process this information, but also we needed a way to do it in a custom fashion. So we would have these images, but we looked around at the tools in ImageJ and the plugins available, and we couldn't get the readouts that we wanted. And so essentially, we needed to go down to the lower level code of the ImageJ libraries and classes that they offer. And so essentially we came up with JEX, which is a Java program, but we consider it essentially a databasing front end for batch Java data analysis. And I put databasing in quotes here because it's not like an Omero database where you have a server and a client and transactions. It's just much more a tool to organize your images that you have and annotate it. And I also say data analysis instead of image analysis because it's fairly agnostic to file type. But basically allows you to apply Java-based code snippets to whatever data you might have. So that's generally what JEX is really good at, is applying whatever code you have to many groups of data in parallel. And so to just illustrate that, here's a random image that I pulled from a Nature Methods paper that we're not related to in 2011, but it's a 96-well plate, and in each well they had 8 zebrafish embryos. And so you can imagine you would want to do some extensive imaging on each embryo, and so you can imagine a multi-channel montage Z-stack time-lapse. And we've seen a lot of tools over the past couple days that would help you to take that image set and translate it into visuals and data. Examples like Cell Profiler, KNIME, IC, and the various scripting capabilities of ImageJ. But essentially, I'm lumping that all together into there's some type of code or workflow that you have to take these quantized sets of data and turn them into what you want. And so what JEX is really good at is taking what's on the left and organizing all the information you have and annotating it in a way that you can feed it to these workflows in an efficient manner. And so the typical workflow in JEX is you import and organize and annotate your data, and we try to make that simple. But then now it becomes easy to batch process your information. So database objects go into your functions and database objects come out. And so it automatically does all the file manipulations for you. And then you can do the statistics and visualizations however you choose from there. But in order to enable this workflow, we use a lot of open source libraries such as CIFIO and bioformats for image importing, and also the SciJava plugin framework, and we're beginning to use the ImageJ Ops framework as well. But some other open source contributions such as RServe and Java Octave, which allow you to call R or Octave from directly within your little Java code snippets that you would like to apply to these groups of data. So it's a very quick lightning demo. I have a little movie here. But this is what JEX looks like when you pull it up. And basically, we're looking at a database, and within a database, you create different data sets. So I'll show you that here. So we click the button. You can name a data set, annotate it in any way you want, and then we're going to create different containers within this data set to organize our data. So here's one data set that has 4 containers for information, another one with 12. And you can select these different containers and look at what data objects are in them and what those data objects contain. So we go to the array view. Here's an image object that's selected, now data table, now image object. Within this image object, we have many files. You can open them in the default viewer, do what you want with them. But you can also double-click the image icon and open up an ND image viewer. And so here we're flipping through the Z-stack. We're adjusting image intensities. You can create and manage ROIs and apply ROIs across the different dimensions of your data set. We also have an importing wizard in Jex to help you import files and distribute them into these different containers. And then we can also label these different containers with things like, oh, what cell type did I use, the treatment condition, et cetera. And those become objects within your database that then can become inputs to these functions. In the batch processing pane, I double-clicked a workflow. And so these boxes up on top are different functions. So you can drag outputs from one function to the input of another, et cetera, or objects from the database to inputs of functions. Likewise, you can click on each function and see what parameters they require, edit those parameters. You can run these functions individually or as a group with the run button on the right. There's a batch queue. You can cancel these things. On the right side, you have a function library where you can organize essentially your snippets of code that you have for each of your projects. And here we have a section of snippets of code that are essentially ImageJ commands that can automatically be converted into Jex functions because we use the same SciJava plugin framework. So that was very lightning fast, hopefully, but you get a sense of it. But basically, Jex stores all your information in a simple folder structure. So put it on your favorite USB drive, external drive, server, and you can peruse it with just a simple file browser, and all the naming looks like how you see it in Jex, and so everything's very intuitive. It's not destructive, so what comes into the input is not edited. We only create new outputs. It's agnostic to file type, as I said, and the GUI matches the layout of well plates and arrayed devices to make things more intuitive. And as I said before, you can annotate your database's data sets and wells, and also store your workflow functions and parameters and share those workflows and databases. But it's essentially all enabled by creating this front end that organizes your data, and then you can apply these, apply a simple function template where you insert your Java code to do what you want to do. And so to just quickly highlight some applications where we've used this, the first of which is chemotaxis that Erwin is interested in. And just to highlight one example of that, he created a chemotaxis microfluidic device to look at neutrophil migration. So in this device, you can create a gradient and look at how these cells migrate in response to that gradient. And so the challenge that Jex helped him face was he had arrays of these devices across many different conditions and then also across different days, let's say even following patients. But he had some custom analysis that he wanted to do, so there was a traditional tracking approach and then his approach that he wanted to try out, and then the custom visualizations that he wanted to use to help interpret that data. And Jex essentially allowed him to then apply that motif across these different conditions and across different days. Here's an example from Edmund Young, who's a friend and was a previous lab member in the MMB lab. But he was a novice programmer. He didn't know how to use Java, but he was able to use the APIs of ImageJ to be able to learn what he wanted to do. And so it was something simple, relatively simple from what we've seen at the conference, but looking at nuclear localization of NF-kappa B in patient samples. And so he had the challenge of trying to organize all this patient data across months of work, and Jex helped him to do that and applied his algorithms uniformly and objectively across his data sets. And then I'm using it more recently to look at single-cell virus host interactions. So I have imaging data from microwell arrays. I can seed a droplet over a microwell array. Cells fall into the microwells. These microwells are about 50 microns on a side. And so randomly, you can isolate single cells. You can put a lid over the microwells and essentially then now isolate each microwell from one another to do separate analysis where you no longer have to track these cells. Essentially, they're contained within the microwell. The virus and the hosts are fluorescently engineered, so we can essentially look at the battle going on between the virus and the host, looking at the fluorescent kinetics of the situation. And so down here is a movie that is essentially automatically generated in Jex. So this is through our connection to R to generate the plots, but then we can also use ImageJ, AVI, making capabilities, etc. And but also we can just simply export the data to R to do the deep data digging that we wanted to do to look at the kinetic parameters of these virus host interactions. So hopefully that gives you a quick overview of Jex, but it's basically something Erwin and I use as needed and have created, but if it helps you, that would be wonderful. There's some links you can find if you would like to check it out. But I'd like to thank David Beebe and John Yin, previous advisors who's helped support this indirectly, and LOCI, with especially Curtis Rudin, who's even contributed to the architecture of JEX and been a great person that's taught me a lot, and then Kevin Elsier for helping support that interaction. So with that, I'd like to take questions.